I want to show you how the Hacktron Whitebox pentest works, and as an example, I am going to use the OAuth 2 proxy version 7.15.0 because recently our researchers at Hacktron reported critical 0 days in it. But to understand the impact and context of the issue, let's first look at what OAuth 2 proxy even is. OAuth 2 proxy is a widely used open source project, and it's used in everything from small internal tools to large enterprise platforms. OAuth 2 proxy is a proxy, so it sits in front of your application and handles access control. When a request comes in, it checks whether the user is authenticated. If not, it blocks access and shows a login page, and it supports different authentication providers like Google or GitHub. After a successful login, the user request is forwarded to the actual app and the user can now use it. So you can put it in front of anything. It could be used as the main authentication for an app or just protect something like a staging environment without changing the application itself. So an authentication bypass is the most critical issue you can get. So let's see how Hacktron Whitebox Pentest could have found this issue. First, we log into the platform and connect our GitHub repositories. Once connected, you will see all repositories here. Now let's run a new pentest. Of course, you can select a connected repository, but you can also upload an archive or simply specify a public repo, which we will do with OAuth 2 proxy. And let's select the vulnerable version 7.15.0. You can also add multiple repositories if your application is split up into smaller microservices or you have a separate front-end and back-end repository. Next, we can define a target for dynamic testing and configure access instructions with credentials. This is helpful information for humans triaging findings. By the way, we are constantly working on our capabilities for dynamic validation and black box testing, so it will also play a larger role in the future. For now, let's continue to context documents. If you have any kind of documents not already included in the repository, for example, architecture overviews, threat model documentation, security audit guidelines, or simply areas you are very interested in or that you want to exclude as out of scope, you can specify them here. But I will not do that now, I will just continue. Before we can start the scan, we need to check what it will cost. This depends on a lot of factors, primarily the amount of code in your repository. This is a small repository, so it will just cost 100 credits. And now all that is left to do is to decide whether we want to commit to the test or not. And that's it. Hacktron will now start the scan. Here's what's happening under the hood. Hacktron first builds an understanding of your application and its threat model. It looks at the documentation, constructs a call graph, maps the attack surface, and then uses different strategies, obviously with AI, to search for vulnerabilities. This will take quite a while, depending on the repository, anywhere between 15 minutes or several hours. Like a human researcher, Hacktron generates hypotheses about potential issues. You can see those ideas here. But also like a human, most of these ideas are wrong, duplicates, or they are just not interesting. So we run them through a multi-step triage pipeline where agents try to confirm or disprove each finding. If you're curious, you can click on them and get a bit more details. For example, this issue here is currently being validated. It found that routes configured with skip auth route skip authorization checks. If it were misconfigured, it can inadvertently expose sensitive endpoints. But eventually, this issue gets dismissed. The reported behavior is an explicitly documented feature intended to allow operators to define allow lists. And this is the power of AI security scanning compared to traditional static code scanning. It can understand the context and threat models and can decide whether something is a documented risk or a vulnerability. Now, let's fast forward to the end of the scan when all the potential issues have been validated and deduplicated. Now, you could look at the preliminary findings here. AI is incredible, that's why we are building Hacktron. But at least for now, we believe the findings you should actually care about come from humans reviewing and prioritizing them, not from raw agent output, just a last layer of filtering. As we are optimizing this and models get better, there will be a time where this is fully automatic. But we believe in quality over quantity. And that's also where configured test target and access credentials can help us. Every Hacktron pen test ends with one of our researchers looking at the findings, cutting the final noise, adjusting severity, and delivering a final report. The same deliverable you would expect from any top-tier traditional pen test firm. Once the findings have been triaged, you can download the report and look at the findings in detail. For example, here's one of the 0 days we reported to OAuth 2 proxy. Authentication bypass via X-forwarded URI header. And of course, you can now copy the finding and paste it into your favorite agentic IDE to get the issue fixed. By the way, this finding is also related to a special configuration. However, the vulnerability exists with the configuration used as intended. And that's the power of AI. With proper context and understanding of the threat model, it can differentiate between the intended feature and a vulnerability. If you want to see it for yourself, sign up to Hacktron and run your first AI Whitebox pentest.